9702, February March 2023, paper 5, variant 2, question number 2. A student investigating standing waves in water. A sound source is placed at the bottom of a cylinder containing water. A microphone is attached here, right? Is attached to a rod and is placed above the sound source as shown in figure. So this is the microphone with the sound source. So the distance is d, right? And we know the standing waves this is a case of a closed pipe. So at the bottom it will have a node, and then at the top it will be an empty node. So this will be perhaps a possible loop in understanding this. The sound source is connected to a signal generator. The microphone is connected to an oscilloscope. The signal generator is set to a frequency f. The microphone is moved up away from the sound source until the maximum amplitude is observed on the oscilloscope screen. The distance d1 between the microphone and the sound source is measured. The microphone is moved up further 2 centimeters. The microphone is then moved down until the maximum amplitude is observed on the oscilloscope screen. The second value, D2, is measured. The average value of D is calculated. The experiment is repeated for different values of F. It is suggested that F and D are related by the equation. Here is the equation. V over F equals 4D plus K, where V is the speed of the sound in water and K is the constant. The question is, a graph is plotted D on the y-axis against 1 over f on the x-axis. Determine expressions for the gradient and the y-intercept. Okay, so first thing first, if we see the equation, if v over f 4d plus k, and it is given as on the y-axis is having d, and x-axis is having 1 over f. So we will put d in one side of the equation. So v over f and 1 over f. So here v over f equal into 1 over f minus k is equals d. So d will be, if we equate with y equals mx plus c, right? So d will be your y, 1 over f will be the x, and v over f will be the gradient, and minus k will be the y-intercept. So the if the possible graph should be like this, if b on the y-axis, 1 over f, the x-axis, we will have the gradient, and the y-intercept we will get as minus negative y-intercept. So gradient is equals to v over 4, and y-intercept is k. So after plotting the graph, right? So we have given the values like f, and its f is in base to the power 10 power 3, so it's 1.5 into times power 3. Then we will get 1 over f. 1 over f is 0.67, 0.48, 0.36, 0.24, 0.19, and of course, if it is f in the denominator, the 10 power 3 will be 10 power minus 3, right? So we will be plotting on the x-axis is 1 over f, right? So remember, this is 10 power minus 3, right? Then we have d1 and d2, do different values of d's, and then we will get the difference in d's, and with the having absolute uncertainty. So d1 plus d2 over 2, plus minus d2 minus d1 over 2, right? So this will be the difference, this will be the gradient, so 24. Now we will need to check for 1.5, we will have something, right? So, but if we go through the scale, we could check that one decimal place on the y-axis is 2, right? So it's here it will be 5. So one small division is equal to 2.02. So 4.2, 4.4, 4.6, 4.8, and that's 5. So one small division should be zero point 0.2 on the y-axis, and on the x-axis, one small division equals 0.01. So it will 0.21, zero point 0.2, zero point 0.3. Likewise, after 10 decimal places, it is 10 division, it will be zero point 0.3. So on the x-axis is 0.01, and on the y-axis is zero point 0.2, right? So that means if we have like this, so we will take two decimal places as for f, 0.61, 0.62, 0.63, and so on. And here it will be two decimal places. One division is equal to two decimal places. So we should take only one decimal place, 24.7, 17.6, right? And another will be 17.8. Likewise, and same as if we having the value in remember it is in centimeter. So 24.7 with the having the decimal place, right? One, right? Because we don't have a provision go beyond that, right? So we will be having these values, right? And now it has been asked that we should plot the d against 1 over f, include the error bars, right? With these like we have, right? Draw a straight line of the best fit and the worst fit acceptable straight line on your graph. Label both lines. Okay, determining the gradient of the line. So after plotting these values, we will be having these, and we have marked the worst fit lines, acceptable fit lines, and the best fit line, right? So we will be having this, right? So if you see, it is going in the negative y-axis, right? For the y-intercept, okay, this thing, right? So after taking the gradient, I've taken these values like for the best fit line, we have the grade points 0.55 against 20 and 0.28 for the y-axis 10, right? And for the worst fit lines, we have 0.1966 and 0.5420. So gradient for the best fit lines y2 minus y1, uh, y2 minus y1 with having centimeters, so we will convert into meter after multiplying with 10 power minus 2, and the frequency, which is it is in the 10 power minus 3, x2 minus x1. So after solving it, we will get the gradient as for my lines. I've taken the gradient is 37. Same with the gradient of the worst fit line, I got 382. So 382 minus 370, the delta m, right, is 12. So 370 plus minus 12, and the gradient is meter per second, because if I solve the d and f, right, d is 1 over f is df, the distance is meter, and frequency in this second inverse, so it will be meter per second or meter hertz, right? So gradient like best fit, which is in the gradient slope, and the best fit minus the difference between the best fit and the worst fit, right, will be the delta. So we'll have to this in further calculation now. Determine the y-intercept of the line of the best fit. Include your absolute uncertainty in your answer. So we have the equation for the best fit line. We say it's YB means best fit, XB and HC. And we have chosen the value which is, I have taken the value somewhere here, where the best fit and worst fit points are actually the same. So it is 0.25, 8.85 for the both. So 8.85, luckily I got this value, right? So 8.85 times 10 power minus 2 to convert into decimeter, centimeter into meter, and 350.25 10 power minus 3 plus CB, right? So after calculation, we got minus 4 into 10 power minus 3 for the simplicity sake. I use significant figure. So for the work, same as the worst fit line, yeah, as we have got the worst fit gradient as 382, right? So 382 times same point 0.25 into 10 power minus 3, and for the y is 8.85 into 10 power minus 2, and after calculation we will get the C y intercept for the worst uh, fit line. uh, Worst line is minus 7 inches per actually. So difference is 4.0 plus minus 3. So 4 minus 7, 7 minus 4 is 3. So 4 plus minus 3 would be the y-intercept, right? Next, using this answer of C3 and C4, determine the value of V and K. So approximately we know from the definition and from the formula, the slope is V over 4. So we will get V is 1480, which is approximately 1500 meter per second. So in this equation, equals V over 4 equals M, having two variables. So delta V over V plus delta M over M, we will get delta V over 1500 equals 12, which is the gradient, absolute gradient, right? Uncertainty is 12 over 370, right? So delta V we got 48.65 again, which is approximately 50 meter per second, right? So our V will be 1500 plus minus 50 meter per second. And y-intercept we know we got is a K. So K will be 4 plus minus 3, right? Into 10 power minus 3 beta, right? Now, the experiment is repeated. Determine the frequency f that gives the value of d. So they are not talking about any absolute uncertainty thing. So we will just put the formula, use the formula V equals V over 4 equals 4D plus K. So F will be V over 4D plus K. So 1500 times divide by 4, and this is D was 30 centimeter, right? So if we make it as a meter into three significant figures. So significant. So it will be 300 plus 4, right? K is also in 10 power minus 3. So we will take that by 3 as a common. So we will get the F is 1233.55, which is approximately 12.240 hertz. So that is our question number 2.